Hello and welcome. My name is Aaron Browning. This will be a section on postulates. It's going to be corresponding to Chapter 2, Section 5. Our main goal is to distinguish between undefined terms, definitions, postulates, conjectures, and theorems. So a little bit about proof background. I'm going to move this up. Right here are 5 things, which we've already talked about a few of them. A definition is something that you should already know, but it's a meaning given to a term. It is the formal statement that describes what the term is. So it describes what the term is kind of what we're going to highlight as our key idea here. Now, a conjecture, we already talked about, is a statement that may be true, but has never been proven. It is guess based on known information, so like a pattern, and it's neither been verified nor has it been shown to be false, because it could be true, it could be false, who knows? It's a conjecture, it's an idea, an educated guess. A postulate is the new thing we're going to be talking about. It's a statement that is accepted as true that has no proof. And that's kind of the foundation of some of the mathematics. You kind of need these postulates, especially for geometry, as foundational things that you can't really prove, but you're basing everything off of. Now, a theorem is what we're going to be starting to prove, which is been proven to be true. So that's the biggest thing. It's something that you can deduce with deductive reasoning, like rules and all the things like that, or definitions and other theorems we can use to create this logically. And the last one is undefined. It's a term that is not given a formal definition. So that kind of is like a point, a line, a plane. And undefined terms are just the basic concepts understood intuitively without any definition. So it's like kind of basic. And there's nothing else we can use to represent those terms because they're the very basic concepts. Postulates are assumptions that are accepted without proof. So it's like a conjecture without proof used to develop geometric reasoning. And it's a little bit difficult to understand sometimes, but we're going to go through and just kind of figure out the difference between all of these with a few examples. Examples usually make a lot more sense when you read them and then look at which one is which. So, Chang is trying, that's a good keyword here, so, oops, sorry, I moved that up too far. Chang is trying to prove, we're trying to prove a statement about prime numbers. He believes it is true. No proof of the statement exists, so that is something to know. There's no formal proof that exists. This statement is best described as what we call a conjecture, because we are looking at it and we're going to be trying to prove it. We're coming up with this idea, this statement that all prime numbers, about all prime numbers that he believes to be true. It could still be false, which a conjecture can be true or false. We just don't know. We have to prove it yet, which is kind of what we're saying in these words. So that's called a conjecture. Now, if we proved it, then it's called a theorem. So this next one, it says Yolanda proved. So she proved something is true. That's a fundamental statement about polynomial functions. So if I actually prove like a conjecture or something, that is then called a theorem. And let me write that down. I think that's how I spell it. So theorem. So theorem is actually proof. So it's a conjecture. It's trying to prove versus being proved. They're different. So conjecture that's proved is called a theorem. Now let's read the next one. Lucy wrote a proof that included the following statement. So we're not really looking too much at this word yet. The statement formally describes what a right triangle is. So this statement, a right triangle is a triangle with one right angle. So what is this statement right here? So if I'm figuring out this statement that's describing things, so if you think about that, a definition is a meaning given to a term which describes what the term is. So remember, this would be a definition. So let's go ahead and write this down. Definition. And the key word there is it's describing things here. Now, the next one, Dan wrote a proof that included a certain statement. That statement is not a definition, so that's something key here. Not a definition, but it is accepted to be true without proof. So something that's accepted to be true without proof. Remember, that would be called a postulate. Postulates are statements that are accepted to be true but are not definitions. Postulate is how we spell it. And we can just look at those proof backgrounds, those 5 different things again. Just kind of look through those key words. Okay, one last one here on this page before we do one more, and you can try it. In her textbook, Salma found a proof of a certain statement about right triangles. So she found a proof of a statement about right triangles. So it is a proof. So if you found the proof, it's showing that that conjecture about right triangles, it has to be true because that was proved. If it's proved to be true, this is then a theorem. So let's try one more of these together, and then I want you to check your understanding as our last thing today. Charmaine read a proof that included a certain statement. The statement's not a definition again, but is accepted to be true. So something that is not a definition, but is accepted to be true, not a definition, accepted to be true, is called, again, a postulate. If you just read the words and match the idea, we would have our answer. Now, Karen is writing or wrote a proof that included the statement about the lines. Line is best described as a what? So remember, in our key vocabulary, lines are going to be one of those undefined terms. Undefined term. And again, points, lines, and planes are those very basic undefined terms that will basically use their concepts we have to start with that are intuitively true without kind of any definition. We don't have terms to talk about them really that are, because it's so foundational and basic. So let's go ahead and write about this next one. So Austin claimed that a certain statement about rational numbers is true. So he's claiming that it's true. Then he was able to actually prove that claim. So it's a conjecture when he claims it, and then when they prove it, it is then a theorem. So once you prove a conjecture, that's called a theorem. So then, if we look again at the next one, again, Mary claims, again, that's a conjecture, that a certain statement about a polynomial is true. The statement has never been proven, so very similar to the other one. So if it's never been proven, then this is just simply a conjecture. So difference between the two is, again, never been, and then it was able to be proved. So just watch for key words. Okay, the last one together, Donna believes that a certain statement about right triangles is true, although there is no proof. Again, so she believes that it is true. So she's kind of making that conjecture about right triangles. The conjecture again, but there is no proof again. So if there's no proof, this is still just the conjecture. So a couple conjectures. Again, if you believe something to be true or claim it to be true, that is a conjecture. And if we never prove it, that still remains a conjecture. But if I actually do prove it, like up here, it was able to be proved, then it turns into a theorem. So let's go back down here, and I want you to check your understanding on these ones right here. So let me highlight it there. Okay, so pause this, and I'll have answers shortly. So hopefully you did in fact try it. We're guessing, no proof, conjecture. It's not a definition. It's accepted to be true. Hence postulate. Plain, one of those key undefined terms that we have. Describes what the midpoint statement is. Something that's describing is a definition. I'm guessing. Found a proof. So there is a proof to what a conjecture is. That is a theorem. So go ahead, as our last thing, is look at the main ideas and write down what you think are the main ideas we learned today.